Welcome everyone to the beautiful session we are going to take. Today's topic is Introduction to Natural Language Processing, which is a beginner friendly session actually. So let's deep dive into this without any further ado. Let's get started. So, natural language processing. And I am Sojibul Rana here for guiding you through the session. Well, begin the core session, we just wanna make you think of a little bit. Do you ever think of how the softwares or machine really understand English or other language? Like we have used a lot of services already, didn't we? We know that computer program there is something called computer programming language, okay? Softwares and other computer actually understand programming language. They directly don't know how to read the programming language, but ultimately the programming language get converted into zeros and ones, which is called code, and then they understand it. But how the actual softwares or the computer really understand the natural language we speak in English, Bengali, Spanish, and other language. How the computer know what is this we are talking about. So we are going to discover how the computer really understand a language like English. So let's go to the overview. Okay, what we are going to discuss about today, we are going to discuss about what is natural language processing, and then we will have a real life example of natural language processing used in softwares. Then NLP steps. This is actually the topic of this video. And today's session we are going to talk about this NLP steps. So this is the fundamental we are going to talk about: segmentations, tokenizations, stopping words, stemming, lemmatization, parts of speech, named entity, and at the very end of this session we're gonna see a Jupyter notebook example how really we are going to actually execute all those things in the Python code. So what is NLP? Well, NLP, or natural language processing, is a branch of artificial intelligence focused on enabling computers to understand, interpret, and generate human language. So, NLP, or natural language processing, is a branch of artificial intelligence which helps the computer to understand what is the meaning of the language we humans speak. It analyzes texts and translate dialogue system, and with applications ranging from virtual assistant to sentiment analysis tools. So like we are going to see the tools we actually use, like real life examples of the natural language processing used in many services like Google Assistants. We have been using Google Assistants and Google Translator for a very long time. Okay, they understood the language we used. Okay, like Google Assistant, we can speak directly to the Google Assistant and they can recognize our voice and then give us suggestions. Google Translator, we can actually translate any language to the Google Translator, and this is the beauty, like how a machine can understand what you are saying and then giving you answers in your language. ChatGPT, the recent AI model, it also know how to speak in your language, which is called natural language. So let's just begin with the NLP steps. What are the steps behind understanding the natural language we speak actually? So first of all came segmentation. Segmentation is like, here we have an example. Like we have a string or text of, we just have a paragraph. Okay, so segmentation means that from this paragraph we will extract all the sentences out. Like here are three sentences in a paragraph, so segmentation means that you are separating out each sentences, and this is the segmentation. Okay, it was easy, isn't it? Then came the tokenization. Tokenization is like breaking down the sentence. It that simple. Okay, Tokenization means, here we have the example. Today we will understand tokenization, and after the tokenization we will have every sentence, sorry, every word is a token. Like if we have a comma here, so comma would have give us another token, okay, comma or period, which is known as full stop. Every part of a sentence is a token. So when you break the sentence into this kind of stuff, this is called tokenization. Then came the stop words. Stop words are the words which are not, which gives less information in the sentence, okay. Like if we see which are the stop words, are, so, and a. So if you look at the sentence and give a close look to each words, like you, helpful, kind, hearted, and person, this gives much information than the are, so, and these words, okay. Why? Because look at you, helpful, kind, hearted, and person, these are nouns and other things, but what are the are, so, and these are called conjunctions, articles, this kind of stuff. The conjunctions, articles, these don't have their own value because they don't carry much information itself. But rather helpful, kind, hearted, person, these actually bear information on their own. So these are the original words, and the articles, the conjunctions, these are called stop words actually. Stemming is another part of the process of natural language processing. If we look to the example here, we have three words like wait, waiting, await, and after stemming these three words we will gonna have wait. Let me give you two more example: keep, keeping, and keeps. After stemming these three words we will gonna have the keep word. Study, studying, study. After stemming this we're gonna have study. So what is the basic idea of stemming? Stemming is finding the common part of all those words. We have, like, in a paragraph maybe we have 10 words. So stemming means finding the common part of these words, okay, like wait, waiting, wait, await, all those words contain the wait word, so it is the root word. So finding the root word is the stemming, okay. Keep, keeping, keeps, all came from keep, so keep is the stemming word, okay. Studies, studying, study, study is the common between all these three. The stemming is this thing. Lemmatization, okay. Well, it's lemmatization or lamination, okay, whatever it is. Lemmatization is the concept of, like, it is similar to stemming. Like before we talk about stemming, stemming and lemmatization is kind of similar, but lemmatization have the context of the sentence actually. We can see the example here. If we do the study, studying, and study, if we lemmatize this thing, we're gonna have study with y, and if we stem that thing, like if we do stemming on this thing, we will have a study with I. So stemming is just finding the common part between all these things, but lemmatization is all about finding the root word with the context, okay. After the lemmatization we get a word which always carries, which is a valid word actually, which actually have information on its own, but after stemming it may or may not be a proper word actually. So this is the difference between lemmatization and the stemming. Then came the parts of speech tagging. So what is the part of speech tagging? In a sentence like you are a kind-hearted person, we know that you is a pronoun, are is a verb, a is an article, kind is an adjective, hearted is an adjective, person is a noun. So these kind of things that after putting a sentence to the machine learning model, this is the way he can actually identify which word is which parts of speech. And here we have a note that parts of speech tagging is dependent on the context of the sentence. Same word can have multiple parts of speech tag. uh, it is actually the truth. If we consider an example like Google it, here Google is a verb. Okay, Google it, Google করো, ঠিক আছে, Google it, here Google is a verb. But when we say like, let me search this word in the Google, so here Google is a noun. So Google at the same time can have the tag of verb and can have a tag of noun. And depending upon the context, a single word can have a multiple parts of speech tagging. So this is a part of natural language processing. Next, we have named entity recognition. What does that even mean? Here we have an example like today's no, sorry. Twitter's CEO Elon Musk will go to attend a meeting at California. Here we humans know that Twitter is a company, Elon Musk is a person, California is a place. But how a machine learning model will understand this? This Twitter is a company. For a machine learning model or computer, everything is a text. So we know Twitter is a company because we know the history of Twitter. Elon Musk is a person we know because we have a lot of context related, connected to Elon Musk. And California is a place we know because we know the geography. So name entity recognition is dependent upon the history, the geography, and all other stuff. So to making a model understand the named entity recognition, we have to make them understand of history, the geography, and the context of a lot of things. So after we done this, the machine learning model can actually understand that Twitter is a company, and this will save a lot of time because Twitter is a company. He can understand, or he can understand it in a single beat of moment. Elon Musk is a person. Normally, Elon and Musk, these are two similar, two different words. But when the machine learning model has the name entity recognition, he can easily understand Elon and Musk together. This is a person, and he is the CEO of Twitter, or X, for now. So now we are going to give you an example of the natural language processing and all the steps. Actually, we are going to show you all the steps: segmentation, tokenization, stop word, then stemming, lemmatization, and part of speech, named entity recognition in Jupyter Notebook. So like go to the Jupyter Notebook. So here we are. This is the Jupyter Notebook. I have already written down all the stuff actually. So we're going through this. We will going through this whole notebook. So introduction to natural language processing. First of all, you need to actually install the NLTK. NLTK is the natural language toolkit. If we want to actually do natural language process, we have to have the package NLTK. So I definitely have already installed this thing. So if you have already installed the NLTK, you don't have to, but this is the step. So we have a text here. Okay, this is the text. Okay, this is, we put this in a variable called text, and we are just going to print this. So this is the text. Okay, this is a paragraph. We can say this is a paragraph. So now we are going to segmentation. We're going to segment these things. After segment, we will have the sentences in each segment. Okay, so to do segment, we need to import the NLTK. The NLTK is the natural language toolkit, and NLTK downloader. These are the packages. Okay, from NLTK, we actually imported send tokenizer. Okay, split text into sentences. Here, this is the part where we actually tokenize the text. Text is the whole paragraph. Actually, we put the whole paragraph in the variable called text. So here we're gonna split the sentence and tokenize. We have to actually run this thing before running that. Okay, now we can see the sentences. Like sentence number 2 is Queen Camilla was crowned alongside him before. This is the segmented sentence. If we can actually see different sentences, like the number 1, the ceremony was held that way. So you get the idea. The number 2 is Queen Camilla was crowned. Okay, punctuation removal. Punctuation is the commas and the other stuffs. Okay, tokenization. In the tokenizations, we actually going to tokenize the whole sentence. So let me just run this thing first, and then, so as you can see, tokenization is the making part of each word, taking the sentence and making part every word. So here we can see the sentence, and here the sentence after the tokenization. Here Queen is a token, Camilla is a token, was is a token, crowned is a token, alongside is a token, him is a token. Here, and it goes actually. Remove of stop words. So stop words, here we come to the stop words. After executing this, we're gonna remove all the stop words. Let me just execute. So here we can compare this, like before the tokenization, before removing the stop words. Here is the example, Queen Camilla. So Queen Camilla, we have Queen Camilla after the stop removing the stop word. But before the before removing the stop words, we had was, but after removing the stop word, we don't have this. Similarly, to, these are gone from the sentences. So this is after removing the stop words. Stop words were the was, a, to, which do not give much information to the sentences. Okay, these are the stop words actually, which we are talking about. I, me, my, myself, we, our, ours. These are the stop words. These are called stop words. A, and, the, and, but, if. These actually don't have too much value of its own. That's why it's called stop words. Stemming and lemmatization. Okay, I have hard time actually pronunciate that. Okay, stemming and lemmatization. Okay, these are the dependencies. We have to do that. Stemming, we are gonna stem. Okay, after stemming, what happened is, okay, let me show you. If we have, okay, here we had the word crown before lemmatization. Okay, but after the lemmatization, we have the word as crown. So it brings the base word of crowned. Well, we have 9 minutes. I think I have to make this a little fast. Okay, here we have palace, but look at this. They get after the stemming, palace. So you get the idea. The stemming and the lemmatization. So this is the stemming. Stemming is the finding of the heart of the sentence, which is the base word, and lemmatize is the same thing, but it has the context on it. Like the stem gave us the palace, but the, which is not a proper word, but after lemmatize the thing, we get the palace, which actually is a word which actually bring information. So this is the stemming, this is the lemmatization. Stemming and lemmatization both actually find the base word, but lemmatized is more suitable because it has the context and meaning to the word. Another stemming and lemmatization is the another example of stemming and lemmatization. Waiting, study. So this was the example we are giving in the slide. Stem actually just give us the common between all the words, but the lemmatize actually give us the word with the context, with the proper meaning. Parts of speech tagging. Okay, as you can see, the queen is NNP. NNP, what is NNP? NNP is here we have the list actually, so we can go through this thing. NNS or NNP is a proper or plural noun. Okay, proper or plural noun. Camilla. Crowned is a VVD. VVD. What is the VVD? VVD is verb. Okay, so forms of verb. So after making the parts of speech tag, we can actually the model can actually understand which of the part is of which part of speech. After that, we have name entity recognition. So after the name entity recognition, here we can see the queen is a person, Camilla is a person, crowned is a verb. It is just a parts of speech tag. Okay, we can have the example from here, like the SpaceX Inc. CEO Elon Musk arrived at the STEP Center in the Los Angeles, California. Here, the SpaceX is an organization. How he know that? Because we have done the name entity recognition here. Name entity recognition. So that's why he can understand the SpaceX is an organization. Does Elon is an NNP, but or the noun, proper noun. Musk is person. California is a GPE or the global geographical unit. So he can understand this is the geographical and place. How he know that? He know that because we have trained him with the named entity recognition. So this is the all about today's session. Thanks to everyone, and thanks to Mochen, because I learned the whole thing from his video. So a big thanks to him. We have a 5-minute lapse to the meeting, so we have to actually end this thing here. Let me go to the slide again. Jupyter Notebook, we have done this part. Resource on GitHub. So all the code I have show you here, I will upload this on the GitHub. So I will give you the link on the video, because this I will post this thing on the Dev Change Makers group and the TensorFlow user group Bangladesh. So when I post the video, I will give the link to the GitHub repository, so you can download it and test it on your own. And thank you for joining. Thanks everyone. Today's session was a beautiful session, and I want to end the session here. Hope this session was informative to you, and thanks everyone again.